And Peter Chang is the business development manager and also the co-founder of Skymizer. And he focuses on the topics in hardware, software co-design, and benchmarking on machine learning. He's also devoted on the participating to the MLPerf Tiny and the tinyML communities. He was also the maintainer of SkyPad, an open source performance unit test suite, and ARMvisor, one of the kernel-based virtual machine solutions on ARM architecture. So let's welcome Peter Chang on the stage with a big applause. Thank you.
I'm Peter Chang from Skymizer, and I'm going to introduce benchmarking AI compiler for tinyML market because Skymizer is an AI compiler company. And this is today's outline. I will introduce MLPerf Tiny, the benchmark itself, and then introduce how to optimize AI model from compiler's perspective, and then I will provide our thoughts, our idea to think about for future benchmark design for tinyML market, what kind of information will benefit more for tinyML developers, and lastly will be the epilogue. So firstly, I will introduce MLPerf Tiny benchmark. Why is MLPerf? Is a benchmark. It's benchmark for evaluate machine learning in performance and energy, organized by MLCommerce, which is a non-profitable organization focusing on MLPerf, this benchmark. And there are several categories of MLPerf, including the data center, edge, mobile, and of course, MLPerf Tiny. MLPerf Tiny is served as a machine learning benchmark, inference benchmark for tinyML systems, and assess energy consumption and performance in inferencing visual and audio tasks. All submitters must fit the quality target for each use case. And there are 4 models right now for here, 4 use cases. 2 models for audio, which is anomaly detection and keyword spotting. 2 for visual, which is image classification and VWW. And its target system is actually MCU-based frequency, several hundred megahertz frequency, megahertz flash and SRAM, mini-watt power, and less than 1 million parameters AI models. And for submission, you need to provide several information, including submitters, device description, power processor, accelerators, software benchmark results, and the code for peer review, and lastly, accuracy. But the energy number is optional for submission. And there are 3 processes for submission. First, you sign the CLA, the agreement, and provide your GitHub handles. And you will have a review by all other submitters. All other submitters will be your peer reviewers. And reviewers will fill in objection opinions, and you can base on that to revise your code. And if there's any disagreement, there may be some vote for accepting or not. And lastly will be publication. You need to write a supplemental material to describe your works and join the press conference meeting before publish, and then release on the publishment days on the website. So that's all about MLPerf Tiny. So move on to a little bit technology part, which is optimization. Firstly, I will briefly introduce our compiler, ONNC, and our submissions. ONNC is an AI compilation suite developed by Skymizer for various markets, from cloud, edge, mobile, to, of course, tiny devices. For tiny devices, we use a very special approach compared with others. We use compile AI model to C code, and that use cross-compiler for each platform to cross-compile the C code for the tiny devices. And in this submission round, we compile AI model to C code for Nuvoton's new Maker Cortex-M4 board, and another board, the STMicrocontroller M4 board, because it's a benchmark reference board. So just like the right-hand side graph, you can see we use ONNC to compile model from MLPerf training by TensorFlow Lite and use the CNC library as our backend. So right here, we only use ONNC as a compiler front end. So talking about the submission, we submit 2 numbers. One is for Skymizer's numbers running on STMicrocontroller. Another is we acting as an agent for Nuvoton, which is our partner, and use their hardware plus our software to submit the numbers. And in Nuvoton numbers, we have very competitive scores compared with other Cortex M4 submitters. We have a leading position on it. And besides of that, how about our numbers on STMicrocontroller, which is reference board, compared with other solutions, we reduce 35% latency. At the same time, we reduce 32% energy in the same binary. That's not trade-off. It's reduced at the same time. Why? Because we reduce unnecessary data movement, unnecessary computation, so we can achieve this in the same binary. And maybe some people wonder how we do that. 3 ideas. First, quantization. I will not deep dive into because the Professor Choi have talked a lot of things, so I believe you have lots of idea about quantization. And second is graph level optimization, because we only use compiler front end in this submission, so we could optimize, try to fuse operators and reduce some unnecessary data, unnecessary computation through graph level optimization. And thirdly will be operator level optimization. We will call ONNC library wisely, try to reduce unnecessary computation within every operators. So that's about our compiler optimization part. And move on to our thoughts to future benchmark design. We think there's more, if we can provide more information in benchmark, there will be more informative to tinyML developers when you decide which hardware, which software solution you would like to choose. First, more energy-centric, because as many people know, tinyML, this kind of scenario requires trade-off between 3 parameters: storage, latency, and energy, because it could be smaller, faster, and greener, but to reach every perspective. So provide more energy information will be useful when you decide you want to choose it or not. Second, the whole system view, because right now, benchmarking may be focusing on machine learning, which of course is quite useful information, but sometimes energy or latency comes from the operating system. For example, if you see this graph, you may think, okay, maybe I can use Pixel 4 to run MobileNet V2 because it consumes very little energy in inferencing. But actually, it may be not suitable because Android itself, operating itself, consumes lots of energy. So have a more whole system perspective will be, we think will be have more information to a tinyML developer. Thirdly, will be more comprehensive. If right now tinyML developers will use lots of models to different application areas, different countries. So if we have more data to cover all kinds of application, all kinds of people, all kinds of scenario, there will be more comprehensive and most important, non-discrimination. And I know tinyML have a working group to address this. That will be very helpful to the whole community. So yeah, that's most of part. Last one is the epilogue. Besides of the topic I mentioned, we have optimization on ARM Cortex M4. We also have a RISC-V version in our booth. You can check it in our booth after you have lunch. And second, about MLPerf Tiny, they actually have already decided the next round submission. The submission will be the February 23rd, 2024, and publication date will be March 27, 2024. And they will be add 2 streaming benchmarks, stream denoising LTN and streaming KWS. Of course, it's still under discussion, so there may be some modification, but the submission date and publication date has been decided, and I have checked with the president of ML Commons. They say the date basically confirmed. And lastly will be LLM. Just like Dr. Choi mentioned in the previous talk, there's lots of interesting to how to put LLM on tiny devices. We also have some data about it. Sorry, because the data is in my phone, but it will be some problem with microphone, so I cannot reveal it in the stage. But feel free to ask us in the booth. And thank you so much.